Robots in space.
Hello everyone, I'm Mike DiVerde and I'm an aerospace engineer. Today I'm wearing my 777X shirt. In today's episode of Robots in Space, we will discuss the Chandrayaan-3 mission by the Indian Space Research Organization to the southern part of the moon's near side, where the Vikram spacecraft landed and the Pragyan rover explored. And I'll have to apologize to everyone for my obliteration of all three of those names throughout the broadcast. The Pragyan rover is 3 foot by 2.5 foot by 2.8 feet and weighs 57 pounds. It generates 50 watts with its solar panel. The ISRO made an interesting change between the second and third rover. The wheels now have an imprint of the Indian flag, which was pressed into the lunar regolith as the rover explored. That imprint could last for eons. Here you see the Vikram lander on the moon in a photo taken by the Pragyan rover. The 4 throttleable engines of the lander were capable of throttling between a range of 40 to 100% incrementally in steps of 20%. Vikram was designed to safely land on slopes up to 12 degrees. Some associated technologies include a high-resolution camera, laser altimeter, 800 Newton throttleable liquid main engine, attitude thrusters, Ka-band radio altimeters, laser inertial reference and accelerometer package. Vikram is 9 foot by 7 foot by 4 foot long and weighed 3,243 pounds and can generate 650 watts. This is the remarkable moment when, for the first time in all history, a spacecraft began exploring this southern region of the moon. India got there first. This is a topographic map of 1/4 of our moon, the lower half of the near side. We're going to work our way through a few different views of the moon as we gradually zero in on the part of the moon that India explored with Pragyan. As we zoom in, you will start to see 3 named craters that surround the landing zone: Manzinius, Schaumburger, Bogoslavsky. Switching to photos from orbit, we see the actual geometry of the trio of surrounding craters: Manzinius, Schaumburger, Bogoslavsky. As we zoom in, the larger craters disappear, and we see the local area around the landing zone. It is difficult to understand the topography of the south polar region of the moon when looking at a lunar globe or at a flat-lying plan view of the surface. Here we provide an oblique perspective view on the terrain with optimal lighting conditions to unmask the surface so that the topography is vividly evident. The image was produced in ArcScene using an average visibility or illumination map draped over lunar orbiter laser altimeter digital elevation map with a resolution of 30 meters. There is no vertical exaggeration. The scene features the South Pole's Shackleton crater in the center foreground and several craters, for example, Haworth, Shoemaker, Faustini in the middle distance, and two massifs, Malapert and Leibniz Beta, in the background. This was a product of the Lunar and Planetary Institute Exploration Science Summer Intern Program. Now we will watch an excellent video derived from Lunar Reconnaissance Orbiter images entitled Sampling the Lunar Far Side in the South Pole Aitken's Schrödinger Basin, which is accompanied by a song by my pal Jason Geringer, Your Love is Like Water. Enjoy.
Once said to me that I will miss you if I set you free. I lost my way everywhere I sauntered, a man lost in a world without water. Oh, in this desert I can't go any farther. I won't that your love is like water, like water. Your love is like water. 3 days now since you went away, like a desert storm, you couldn't stay. Oh, when you're gone, I wanna break down and cry. But when you're here, love rains from the sky. Oh, in this desert I can't go any farther. I've been tempted by the fruit of another. Oh, sometimes love takes its time to discover that your love is like water, like water. Your love is like water.
This excellent map was prepared by Professor Phil Stuke of the detailed route of the Pragyan rover. Here is his description. This is my latest version of the Chandrayaan-3 Pragyan rover traverse, mapped using rover images. I think the eastern end near the lander and the western end near the craters are well defined, but the bit in the middle is uncertain. The maps from the APXS team are overlaid on the original ISRO map. This is a close-up of the excellent map that was prepared by Professor Phil Stuke of the detailed route of the Pragyan rover, started at the Vikram lander and following the first half of the journey. Note that Phil has depicted the beginning and end point of the hop that the Vikram lander executed. This is a close-up of the excellent map that was prepared by Professor Phil Stuke of the detailed route of the Pragyan rover, starting at the second half of the journey through to the final position. Quoting from the research paper entitled An Overview of the Scientific Results and Architecture of the Two Modules of the Chandrayaan-3 Mission, the alpha particle X-ray spectrometer APXS, is also a scientific payload present on the rover of the mission. The APXS instrument consists of two packages, the APXS sensor head and the APXS back-end electronics. The APXS sensor head will be mounted on a robot arm. On command, the robotic arm brings the sensor head close to the lunar surface and brings it back up. The primary scientific objective of APXS is to determine the elemental composition of the lunar surface in the region surrounding the landing site by employing the technique of X-ray fluorescence spectroscopy using an in situ excitation source. APXS uses curium-244 radioactive sources emitting both alpha particles having energies of 5.8 mega electron volts and X-rays having energy of 14.3 and 18.3 kilo electron volts, which excites the elemental characteristic X-rays by the processes of particle-induced X-ray emission, PIXE, and X-ray fluorescence, XRF. The characteristic X-rays are detected by the silicon drift detector, which provides high resolution and efficiency in the 1 to 25 kiloelectron volt energy range. This thus allows the APXS to detect the composition of elements like sodium, magnesium, aluminum, silicon, calcium, titanium, iron, strontium, yttrium, and zirconium. Quoting from the research paper entitled Discovery of a Buried Crater on the Moon, Chandrayaan-3 Vikram lander and Pragyan rover landed within it. In the left-hand photo, Chandrayaan-2 orbiter high-resolution camera image shows the Chandrayaan-3 landing site with linear parallel grooves-like structure extending from the southwest to the northeast side and spread to several hundreds of meters. These features indicate ejecta from distant impacts that was placed over the landing site. In the right-hand photo, the Pragyan rover navcam images taken from the south of Vikram lander shows the linear groove-like feature present over the landing site. The other navcam image shows the Vikram lander and the boulder distributed around the landing site. So first, I need to do an explanatory note. The semicircular buried impact crater detection and evaluation model is a tool used to identify buried craters on the moon. Quoting from the research paper again, black arrows show the boundary of the semicircular buried impact crater within which Chandrayaan-3 mission landed. The semicircular buried impact crater detection and evaluation model, draped over the hill shade image to highlight the buried semicircular structure, which is the destination of the Chandrayaan-3 mission. The regional exploration around the Chandrayaan-3 landing site revealed a near semicircular-like structure with highly degraded in nature. This semicircular structure encompassed the Stadio Shiv Shakti. The location is shown on the map by the yellow star, okay, as shown in the figure 2. Further detailed geomorphological and topographical analysis revealed that the semicircular structure is a heavily degraded crater structure or a buried impact crater with a diameter of approximately 160 kilometers. The semicircular structure was highly degraded due to the mantling of thick ejecta deposits from the South Pole Aitken basin and followed by many other complex craters throughout the geological history of the moon. This buried crater is one of the oldest craters on the moon, and the Chandrayaan-3 Vikram lander and Pragyan rover landed and roved within this buried crater, which is hosting the South Pole Aitken basin ejecta material and some of the most deeply excavated materials on the moon. Quoting from the research paper entitled Physical Research Laboratory Built Alpha Particle X-ray Spectrometer on Pragyan rover of the Chandrayaan-3 made the first elemental abundance measurements of lunar soil in the South Pole region of the moon. And that's just the title. According to the widely accepted hypothesis on the early evolution of the moon, the lunar magma ocean hypothesis, the moon was entirely an ocean of magma when it formed. As the magma cooled, heavier minerals such as olivine and pyroxene sank and formed the inner layers of the moon, while the lighter mineral plagioclase floated and formed the outer crust of the moon. The dominant presence of ferroan anorthite in the soil observed by the alpha particle X-ray spectrometer further confirms the lunar magma ocean hypothesis. However, the presence of additional magnesium-rich materials suggests that the outer crustal material has been mixed with material from deeper layers of the moon to form the soil near the Shiv Shakti point. The South Pole Aitken basin on the moon, the largest known impact basin in the solar system, is believed to have formed about 4.2 to 4.3 billion years ago due to an asteroid impact. This impact resulted in the excavation of magnesium-rich material from deeper layers of the moon and brought to the surrounding areas, including the Chandrayaan-3 landing site, which is about 350 kilometers away from the rim of the South Pole Aitken basin. Subsequent cratering caused the mixing of the superficial material with the material from deeper layers to form the soil within the composition seen by the alpha particle X-ray spectrometer. Thus, the new measurements by alpha particle X-ray spectrometer in this never-before-explored region of the moon indicates that the lunar soil is a mixture of two types of rocks, where part of the material is excavated from deeper layers of the moon, providing direct insight into the evolutionary history of the moon. So here is my summary. India completed an astounding mission to the moon, resulting in a lander and rover operational in an unexplored area of the southern region. Scientific instruments determined the elements in minerals there, which supported the hypothesis of the early history of the moon. They also detected an ancient and previously unknown crater. But I believe that the true triumph lies in the demonstrated methodology of landing on and exploring the moon. As humanity recovers that lost art after a half-century of neglect, we will see a resurgence in robotic spacecraft exploration of the universe. Omni Futurists.